Okay, so now we're moving on to this worksheet that you should have printed out or have. Is kinetic and potential energy. And it is so nice because look, it has the rules for kinetic energy. 1/2 mass times velocity squared, rules for gravitational potential energy. And so this is new. So we done potential energy on the other sheet, which just told us that we only need to multiply mass times height. Well, you'll find some of your problems are gravitational potential energy. And that means we just take into consideration gravity. And gravity is what? 9.8 meters per second. It is why you are sitting in your chair right now listening to me and you're so engaged. I do understand. Or it is why, things stay on the earth. It's a myth that there's no gravity anywhere else but on the earth. And that's not true. It's just that our gravity is so heavy, as it shows here, 9.8 meters per second, that it keeps us down. On the moon, though, the gravity is 1.6 meters per second. And so this is why we float on the moon, because the gravity doesn't have enough pressure or force to keep us down. So now that I've given you that tad bit of information, I want to point out the next equation you need to know. So I ended with the last video of the two equations for kinetic and potential energy. And so now we want to pay attention to this equation for gravitational potential energy. It's mass times gravity times height. So as you see up here, mass, kilograms, pounds, tons, whatever a weight is. Gravitational acceleration is always 9.8 meters per second squared times our height. And our height in these problems are usually meters, but height can be inches, feet, yard, whatever. So we'll only take a look at those problems that are gravitational potential energy problems, because those what I want to focus on. So the first thing we'll do is take a look here at number 6, 7, and 8, if I remember. And I think we're about to find out as we're doing this, my memory is kicking in, that some of the answers at the bottom are wrong. So, hey, we'll work this out as I normally do in class and we'll figure it out. So let's take a look at number 6. It says, what is the gravitational potential energy of a 3 kilogram ball, weight, kicked in the air at the height of 5 meters? Height, right? So we have a weight and height. So we know that our gravitational potential energy, right, is equal to mass times gravity times height, right? And so we say that the mass for number 6 was a 3 kilogram ball. We know that gravitational is always the same, 9.8 meters per second squared. And that the height for the ball, it was kicked at a height of 5 meters. Alright, so now we have it. Just that simple. We have the mass, we have the gravity, never changes, and we have the height. And so now we get out our handy dandy calculator, or I do, and hopefully you have yours because you'll need it. So 3 times 9.8 times 5 equals 147. So 147 kilograms times meter over second squared times meter. And I know you're like, really, Dr. Rothal? Well, I have to point this out because you should know that this is equal to what? A joule. Yay! So kilogram times meter over second squared, again, is a joule because kilogram times meter over second is a newton. And a newton times a meter is a joule. Do you really need to know all that? No. But since I know it, I tell you what you should know, that anytime you are calculating gravitational potential energy, your unit is always going to turn out to be a joule. And so this will equal to 147 joules. Now, what I want to point out on my exam is that you may end up with the answer for your exams that would take into account that you missed multiplying by 9.8, or that you missed the height, or that you missed the math. So you really have to be careful when you're doing the problems, because I can be tricky, yes. It's just to see if you really understand what's going on. And so I'll give you any answer that you could possibly come up with in this combination. But know that for gravitational, anytime you're told in that told that gravity is involved in the problem, that you have to use 9.8 meters per second, meaning we're using the gravitational potential energy. All right. So this is how you do it in number 6, 7, and 8. If I remember, are correct on your answer key. 6 is 147 joules like we got. And then you can check 7 and 8 by doing those. I do want to go and do number 1, I think, because if I'm not mistaken, those are wrong. And I think all they forgot to do was do the half. But let's check that out. So let's look at number 1. It says, what is the kinetic energy, of a ball with a mass of 5 kilograms rolling at 10 meters per second? So we have a mass and we have a velocity. And we know that kinetic energy is 1/2 times mass times velocity. So let's go ahead and work that problem out here. So we'll say kinetic energy is equal to 1/2 mv squared. And so this is problem number 1 on your sheet. I just wanted to check because I know the answer key for these are wrong. And I just need to make sure I tell you what's correct. All right. So if we plug and chug, that means that we have 1/2 5 kilograms times 10 meters per second squared. And as we said, we're going to do order operations first. That means we'll do our square first. So that means we have 1/2 5 kilograms times 100 meters squared over second squared. And so 1/2 of 500 meters squared over second squared. And that's right. So now we're going to half. So 1/2 or 500 divided by 2 or times 1/2 gives us 250 joules, right? Because we remember kilogram meter squared over second squared is always a joule. So the answer for number 1 is kinetic potential energy of 250 joules. So your answer key for 1, 2, 3, and 4 is that the person who I got this from, God bless their soul, forgot to divide by 2. So please know that 1 through 5 are wrong because there is no division divided by 2, but 6, 7, 8, and 9 are correct. All right. So I hope that helps. If you want to check and do the other problems, just to make sure you have kinetic energy down to a science.